This video will cover our worksheet packet from FRQ Topic 7, which is horizontal and vertical motion or rectilinear motion. We're going to begin with the problem from 2018. This is from the AB test from 2018. Remember that on the BC exam we focus on motion along a curve, and so the FRQs for the BC test will cover that. I like to do a couple of the AB questions just for a review of everything, and then I'll just do some multiple choice questions on this material, which is quite likely where the BC test will show it. Alright, for this problem it says a particle moves along the x-axis with velocity given by this function for time between 0 and 3.5, and they give us this initial condition. At time 0 the particle is at x equals -5. So they're telling us that x at 0 is -5. Since we're on the x-axis, I like to call the position x. If we have a calculator allowed, I'm going to put the velocity into my y1. Okay, clear this all out. Okay, so I'm going to put velocity in for y1. So 10 sine 0.4 x squared, x will be my t, my time, divided by, don't forget your parentheses around that whole denominator. Give it a quick check, make sure you typed it in right before you go on, because you'll be in a big spot of trouble if you type it in wrong. Okay, so for part A, it says to just find the acceleration of the particle at time 3. So they give us the velocity, we want the acceleration. We know the acceleration is just the derivative of the velocity, but we need to say what we're doing. So I'm going to say acceleration A at time 3 is the derivative of the velocity at time 3, and then we can let our calculator do the rest. So I have the velocity stored in for y1. I need the derivative, so math 8 of y1 at time 3, and that's the acceleration at time 3. So -2.118. So back in 2018, this was worth 1 point for the answer. And remember, you will not get that answer point if you don't show where it came from. So that's not optional. Alright, for part B, find the position at time 3. Well, we know the position at time 0, we want the position at time 3, and we have the derivative of the position, which is velocity. So I'm going to set up first fundamental theorem. X at time 3 minus x at time 0 is the integral from 0 to 3 of x prime, which is just v. And you could go ahead and put v in there for right now. Or you could go ahead and put v in right now, but I'm going to wait for this next step. So x of 3, which is what I'm looking for, minus -5 is going to be 0 to 3 of our velocity function. And the rest can just go into my calculator. So in my calculator, I'm going to pull that 5 over, so it's going to be -5 plus the integral from 0 to 3 of our y1, and we get -1.760. Okay, this part of this question was worth 3 points. 1 point for the integral, 1 point for that integral, 1 point for uses initial condition. That's our x of 0 is 5, and then 1 point for the answer. Next part. Evaluate the integral from 0 to 3.5 of the velocity function and evaluate the integral of the absolute value of the velocity function on those same boundaries, and then interpret the meaning of each. So the first part, let's just go ahead and find these values, and that's just straight calculator work. So integral 0 to 3.5 of the velocity function, 2.844. Remember that AP will accept 843. They'll allow you to truncate it, or you can round it if it can be rounded. I like to round those. So then we're going to interpret the meaning of that. I don't know if I should do it right here, or should I just go find the value first? I think I'll go ahead and interpret this meaning. So remember that this is the integral of velocity, which was what we did right up here. Integral of velocity is the change in position, right? It's the change in position, which is also another word for displacement. So you can use change in position, or you can use the term displacement. I'm going to probably use them both. I'll say this is the change in position of the particle from time 0 to time 3.5. Change of position. And again, you can also say displacement. I said I was going to do that, and I didn't do that, but that's fine. Okay, so that's displacement of the particle from time 0 to time 3.5. Now we're going to go do the other integral. So for this calculator work, I'm going to pull up the integral 0 to 3.5. Now I need the absolute value. The absolute value, the quickest way I know to get to the absolute value function, it's up here in F2. So if I do the alpha, then the window button, I'll get to F2. And the first one up there is absolute value. You can take a look at the other ones there too. That's another way to get to derivative and integral as well as summation, which we very rarely use in calculus. But there's absolute value, and then I need my y1. I'm going to take it a second longer here to get this value with that absolute value. 3.737. So this is an integral that you need to recognize that you know the meaning of this, and that is the total distance traveled by the particle. Total distance traveled. So it makes all of the values of velocity positive. If v is already positive, of course these would be identical, right? But here, obviously, some of the velocity in between those boundaries was negative, and so these are not equal in this case. This is the total distance traveled. By the particle from time 0 to time 3.5. So this part of the problem was worth 3 points. 1 point for the two answers, the calculator work. 1 point, and then, 2 points for the interpretations of the two integrals. So again, maybe they split those up into one of each. Maybe they just took an all or nothing. That depends on the workings at the table that they were grading at, and I'm not privy to that. Okay. All right. Part D. A second particle moves along the x-axis with position given by this function. That's its position for time between 0 and 3.5. At what time are the two particles moving at the same velocity? Okay, so we have the velocity of the first particle that was given to us, and I have the position of the second particle. So the first thing I'm going to do is I'm going to get the velocity of the second particle. I'm going to call it v sub 2 since they called this x sub 2. And the velocity is the derivative of the position, which is 2t minus 1, taking that little derivative. So now I can just set v of t from above equal to v sub 2 of t. In my calculator, I can graph both of those and see where they intersect, and that will be the time that the particles are moving with the same velocity, right? So this will be my answer here. So I'm going to come up here, my y equals, I'm going to put the other velocity in here. Make sure I did that little integral, the little derivative right. And we're going from 0 to 3.5. And I don't know what my y should be. I just want to make sure, well, I need where they intersect, and I really don't know where they intersect. I think I'll go from -5 to 5 and adjust if I need to. So let's see what that gives us. Not bad so far. Let's see what the other one looks like. Yeah, that's not a bad graph. I see that they intersected exactly that one point and only that one point. So second calc 5, enter, enter, enter. And there's the time that these two particles have the same velocity. So 1.571 or 1.570, either one. So this problem was worth, that was worth 2 points. 1 point for sets v of t equal to x sub 2 prime of t. That was our second velocity. And then 1 point for the answer. So hopefully you did pretty well with this one. Okay, so next up we're going to take a look at the AB problem from 2017. This was number 5 and it was not with a calculator, so we're not going to use the calculator on this one. Think of it as getting some practice for the multiple choice questions that you might come across on the BC exam. Okay. All right, two particles move along the x-axis, 0 to 8. The position of particle P at time t is given by this. So there's the position at time for particle P, while the velocity of particle Q is given by this equation. Particle Q is at position 5 when time is 0. So I'm going to say that x sub q for the position of Q at time 0 is 5. So they gave us an initial condition for Q. Part A. For 0 to 8, when is particle P moving to the left? Well, P moves to the left when its velocity is negative, right? So I need to find the velocity of P and see where that velocity is negative. So x sub P is equal to this, and I don't know why I'm rewriting it. That's silly, but anyway, I am, so oh well. The velocity of P will be the derivative of the position of P, and so we need the derivative of this natural log. The derivative of ln of u is u prime over u, little chain rule here. So u prime is 2t minus 2, and then I put that over u. Okay? And I'm going to set this equal to 0. And my first thought is are there any t values that make this denominator 0? Are there any t values that make this 0 on 0 to 8? If you put in time 0, you get this is positive. If you put in time 8, you also get this to be positive. And that's good enough for me. I'm going to say this is positive. This is positive on 0 to 8. So I'm going to go ahead and multiply it on both sides, and then I will just get 2t minus 2 is equal to 0. So t is equal to 1. So that's the value of t that makes the velocity 0 from 0 to 8. And now I'm going to do a little sign chart to see where is v negative, right? So if I put in like a half, if I put in a half for t, the denominator is positive. The numerator, if I put in a half, I'll get a negative on top. A negative divided by positive is a negative. And since this is not a double root or anything, it's going to change, alternate values here. So the particle moves to the left from time 0 to 1. So that's going to be my answer. P moves left on 0 to 1 since v sub p is less than 0 there. Okay, and actually it should actually include 0, because even if I put 0 in for t, I'll still get a negative. So I'm going to include 0 there. Okay, because they told me to include 0. Okay, all right. For same time, 0 to 8, find all the times during which the two particles travel in the same direction. Okay, well, they travel in the same direction where we can do a sign chart for both of them and analyze how they're traveling. So I'm going to pull up my velocity for q. The velocity for q is this equation. If I do the same thing I did above and set that equal to 0, then I can factor this. T and T, 3 and 5, negative and negative. T is 3 or 5. So then now I'm going to do a sign chart, and I'm going to do a sign chart that includes the 1 from V of P and the 3 and the 5 from V sub Q. So from 0 to 8, I need to put 1, 3, and 5 on there. I'm going to put V sub P below and V sub Q above just to analyze it. I already have the signs from P, and that was negative from 0 to 1 and then positive all the way to 8. For Q, the velocity, if I put in, well, I can actually put in 0 here if I wanted to, and I'll get negative times a negative, which is a positive. So less than 3 will be a positive for Q. And then it's going to alternate signs. So there'll be a negative till 5, and then a positive after 5. So the particles travel in the same direction where they have the same sign velocities, right? So from 1 to 3, the particles will travel in the same direction, and then again from 5 to 8 they travel in the same direction. So P and Q travel in the same direction. On 1 to 3 and 5 to 8, and I'm going to include the 8. They told me to analyze up to and including 8, and if we plugged in 8 we would also get positive and positive, so I want to include that 8 there. Since V sub P and V sub Q have the same signs there. Okay. Forgot to give you points on this. For this one that we just did, it was worth a total of 2 points. 1 point for the intervals, 1 point for analysis using v sub p of t and v sub q of t. So 2 points for that one. And there was a little note. They said a maximum of 1 out of these 2 points if only one interval given. So if you only had one interval, you could only get a maximum of 1 of the 2 points, and 0 out of the 2 if no analysis. So again, you can't just write the intervals without any kind of analysis going on, okay? You always have to, even though it says 1 point for the intervals, you can't get that point unless you have the analysis. Okay, and then for up on part A, that was worth 1 point for x prime sub p of t. So 1 point for finding the velocity, the derivative, and then 1 point for the interval. Okay. All right. Part C. Find the acceleration of particle q at time 2. And then, is the speed of particle q increasing, decreasing, or neither at time 2? So first let's find the acceleration of q at time 2. So the velocity of q we were given. That's the velocity of q. The acceleration of q is the derivative of the velocity, which is 2t minus 8. So the acceleration of q at time 2 will be 2 times 2 minus 8. You can safe stop that, or you can take a risk and call that -4. And then, so that answers that first part of the problem, of this part. Then, is the speed increasing, decreasing, or neither? Well, the speed is increasing when the acceleration and velocity have the same signs, and the speed is decreasing when acceleration and velocity have different signs. So I found the acceleration at time 2, and that was negative. Now I want to find the acceleration, the velocity at time 2 and see what sign that is. So at time 2, this is going to be 4 minus 16 plus 15, and that is positive. So acceleration is negative, velocity is positive, so the speed at time 2 is decreasing. So speed of q is decreasing at time 2 since a sub q, the acceleration at 2, and the velocity at 2 have different signs. This was worth 2 points. 1 point for finding that value a sub q, finding this value -4, or the safe stop spot, and 1 point for speed decreasing with reason. Okay, next up, find the position of q the first time it changes direction. The first time it changes direction. So q changes direction for the first time on our interval at time. I'm going up and I'm looking at this chart. Remember that the first time q changed direction on this interval was at time 3, right? So that happens for the first time at time equals 3 from part B. Okay? So I want to know the position at that time. Remember that we were given the position at time 0, and we know the velocity, which is the derivative of the position. So first fundamental theorem. So x sub q at 3 minus x sub q at 0 must be the integral from 0 to 3 of the derivative of x sub q. First fundamental theorem. This is our velocity of q, right? So x sub q at 3 will equal, this is 5, and I'm going to bring it to the other side. And this is our velocity of q, which is t squared minus 8t plus 15. Now we just have a little integral to do by hand, little power rule. So 1/3 t cubed minus 4t squared plus 15t from 0 to 3. Alright, put 3 in, that's 27, divided by 3 is 9, minus 9 times 4, plus 3 times 15, minus, and when we put 0 in for t, we just get 0. And that would be a safe stop spot, and I think I will just safe stop. This was worth 3 points. 1 point for the antiderivative. That's our antiderivative here, the power rule. 1 point for uses initial condition. They like to give a point for that in these fundamental theorem problems, and then 1 point for the answer. So, not too bad. Okay. Let's take a look now at these multiple choice questions that I gave you guys. And this is, like I said, this is how you'll likely see them on the BC AP exam. All right. The first page, I said use your calculator on this stuff. So we will use a calculator. It says a particle moves along the y-axis. This is its velocity, and they want the acceleration at time 2. So acceleration at time 2 is the derivative of the velocity at time 2. So calculator. Let's get back here. Clear that out. Okay, I need the derivative of that velocity. It's just, you know what, I was just going to say it's just a single problem, but I'm looking at this here, and the first 3 problems have that same velocity. I can tell when I put this together, I must have taken an FRQ and just did some different things with it. I pulled it apart. So instead of doing this here, I'm going to go and put that velocity in for y1, since I'm going to be using it a couple times here. So inverse tan of e to the t, e to the x. Okay, make sure I put it in right, looks good. So now here I can just put y1, and then I want this evaluated at time 2. So negative 1.3, I'm sorry, negative 0.133, and that is A, and we go on. Okay. All right, same intro to this. At what time does the particle reach its highest point? Its highest point. Well, let's take a look at the graph of this velocity. We're not given any boundaries except for time is greater than 0. So I'm going to start time at 0, and I don't know where to go to. Maybe 10, I don't know, we'll see. And I don't really know, I just want to include 0 in this. So I'll just do that for now, change it if I need to. Okay, well that didn't give me a real clear graph of what's going on. I think it started positive and then went negative, but I think I have way too many y values. I think I can go negative 1 to 1 and be good. Yeah. So this velocity, the velocity starts positive. At this value of t, the velocity becomes negative, and it's always negative after that. When the velocity is positive, the particle is moving up. When the velocity is negative, the particle is moving down. So it must be at its highest point at that time, right? So if I can find that time, let me go put 0 in, make my life easier here. And then I can do second calc 5, enter, 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 and 0.443. So here's what I'll say for your sake. I'll do this, and I'll say this is the graph of V positive to negative at time, that was 0.443. So the particle has to be at its highest point there. So C. Okay. Same intro. At time 0, the particle is at y equals 1. What is the position at time 2? First fundamental theorem. Y at time 2 minus y at time 0 is the integral 0 to 2 of y prime, which is our velocity. So y at time 2 is equal to negative 1 plus that integral. And now we can just use our calculator. So negative 1 plus math 9, 0 to 2 of our y1. And that is negative 1.361. Negative 1.361 is B. Number 6. Okay, a particle moves along the, and now that made me look at this. I have the same V in the next 3 problems, so I'm going to go ahead and replace my y1 with that V. So natural log t squared minus 3t, and that will not be how it is on the AP exam. They will be totally individual questions for the multiple choice part, okay? Double checking that, making sure I put it in right. Okay. Okay, so there's the velocity. It's all along the x-axis. The particle is at position x equals 8 at time 2. Find the position at time 5. X at time 5 minus x at time 2 must equal the integral 2 to 5 of x prime, which is v, right? So x at time 5, it must equal 8 plus that integral. So 8 plus math 9, 2 to 5 of y1, 12.371. 12.371. So D. Okay, number 7. A particle moves, okay, same thing. During which time intervals for 0 to 5 does the particle travel to the left? Well, the particle travels left when v is less than 0. So I just need to graph this and see where v is less than 0. There's my v, and I already have 0 in here, that's good. So, and I want to be on 0 to 5, so just do 0 to 5. And I only need to include 0. I think I'll go from -3 to 3 and see if I can get a good picture here. And that's a good enough picture. I can see what's happening here. So v is less than 0 between this time and that time, because this is the graph of v, right? So v is negative down here. So second calc 5. Enter, enter, enter. So for the sake of, I'll say this is 2. Okay, and the other one, second calc 5. Enter, enter, enter. Oh, that is 1. So 1 to 2. Okay. Number 8. Same introduction to it, and now we want the speed at time 1.5. So speed is the absolute value of velocity, always. So speed at 1.5 will be the absolute value of the velocity at 1.5. So I just need the absolute value of the velocity at 1.5. I guess I could do it right here. Since I'm on the graph, I might as well just do it. Second calc value at x equals 1.5. There's the value, and I just need to take the absolute value of that value. So 0.288. 0.288 is D. So another way to do that, you guys, would be go to your home screen, y1 at 1.5, and then take the absolute value of that. Same thing. Okay, next page, number 9. Same velocity. Now we want to find the average speed of the particle. Average speed. Well, we just said that speed is the absolute value of the velocity, right? So the average speed would be, we know how to find the average of any function, right? There's a little formula for that. Average of any function. We're finding it from 0 to 2. This is 1 over 2 minus 0, integral 0 to 2 of whatever we're finding the average of. We're finding the average of the speed. So that will do it. So calculator again. 1/2, whoops, 1/2, math 9, 0 to 2, absolute value of y1 and that's our answer, 0.371. 0.371 is C. Okay. All right. New problem, new velocity, and it's not repeated, so I don't really have to put that in for y1, but if you want to put it in for y1, you can. All right. Let's see. That's the velocity. Find the total distance traveled from 0 to 3. Total distance traveled is the integral of the absolute value of velocity. Just got to know that. So I just want the integral of the absolute value from the integral from 0 to 3 of the absolute value of that velocity. So negative x plus 1 in parentheses, and then sine of x squared over 2 dx. Didn't really need that negative since we're taking the absolute value of it, but this is it. 4.334. 4.334, and we're good. Okay. Another velocity, and now what is the total distance traveled from 0 to 2? Okay, just got to know that formula. Okay. So same thing, integral 0 to 2 this time, absolute value of sine of t squared, so sine of x squared .985. 0.985 is B. I'm moving on. Okay. All right. Particle travels along a vertical line. This is its position. What is the velocity at time 3? Well, the velocity at time 3 is the derivative of the position at time 3. So this is just a quick calculator problem. So I need the derivative math 8, of this function. So be careful putting this function in. It's a little complicated. I have first of all, the natural log of the absolute value of cosine of t squared over, I need parentheses around that denominator, okay? I'm going to close the parentheses for my cosine and then go out. And I want to evaluate this derivative at time 3. So 1.161. One bad thing about these calculator dependent problems is that it's super easy to put something wrong into your calculator, and you're totally at the, you need to be careful doing it. Okay, if you have time later, go back and punch it in again. So another B, 3 B's in a row here. Okay. A basketball is thrown upward. The position is given by this. This is the position. What's the maximum height? Maximum height. Well, for me, the maximum height, I go to find the velocity. The velocity will be negative 9.8 t plus 15. And by the way, this is an upside down parabola, right? So I know the maximum height occurs when the velocity is 0, correct? So if I set this equal to 0, I know this time is when we get the maximum height. They're asking for the maximum height, not the time, right? So we need to take that and plug it in for t in the s function here. So the way I'm going to do that, 15 over 9.8. So 15 divided by 9.8, I'm going to store that in for x, and then just type in this equation with x's instead of t's. So negative 4.9x squared plus 15x plus 1. And that'll be the height, the maximum height that it occurs. So 12.480. So A. Last row on this page, particle moves along the x-axis so that its acceleration, here's its acceleration. The velocity at time 0 is 0.2. What is the velocity at time? The velocity at time 0 is negative 2. What is the velocity at time 2? So first fundamental theorem, the velocity at 2 minus the velocity at 0 is the integral 0 to 2 of v prime, right? V prime is A. V prime is the acceleration. So the velocity at time 2 will be negative 2 plus that integral. And that's what we'll put in our calculator. So negative 2 plus math 9, 0 to 2. We'll be careful putting this in. Square root of x, arrow over, get out of the square root, and then cosine t. Close that parentheses around the argument. You're good to go. Negative 1.419, and that was A. Okay. So those were the problems with the calculator, and for the rest of the calculator, or for the rest of this worksheet, we don't have a calculator to use. So we'll have to tough it out, do some things by hand. Okay. Okay, particle moves along the x-axis. Its velocity is given by, oh, this looks familiar. I think we did something with a calculator with that. What is the acceleration at time 4? They give us the velocity, so I know the acceleration will be the derivative of the velocity, right? The derivative of the velocity. So u prime over u, right? 2t minus 3 over t squared minus 3t plus 3. And then we put in 4 for t. And since it's multiple choice, we have to work this out. Let's see, for and for t. So 8 minus 5, I'm sorry, 8 minus 3 is 5. And then 16 minus 12 plus 3, that'll be 4 plus 3, 7. So 5 over 7, and that is answer choice D. Okay. Particle moves along the x-axis so that its position is this. That's its position. What's the value of t that the velocity of the particle is 0? So we want for the velocity to be 0, we want to find that time. So the velocity is the derivative of position. So that is 2t minus 7. We're going to set that equal to 0 and find the value of t. So t is just 7/2. 3.5 C. Okay, this time the position is given by this. And in which intervals is the particle slowing down? Particle slowing down. Remember, that means A and V, different signs. So I need to find the velocity, find the acceleration, do sign charts on both of those. Okay, so the velocity will be the derivative of the position, so 4t cubed minus 36t. I'm going to set that equal to 0. Solve it for t. Factor out a 4t. And we're going to have t is 0 or plus or minus 3. And now we're going to do the same thing with a. The acceleration will be the derivative of velocity, so 12t squared minus 36. Set that equal to 0. I'm going to factor out a 12. We're left with t squared minus 3. So t will be plus and minus square root of 3. And we want to do a sign chart, but only between 0 and 5, right? Only between 0 and 5. So 0, there's 0. Square root of 3 is less than 3, so square root of 3, and then 3, and then 5. I'm going to put V on the bottom and A on top. Of course, that doesn't matter. You can put whatever you want there. So for V, I'm looking at this factored form. If I put something like 1 in, I'll get positive times a negative, which is a negative. And velocity is going to be negative all the way up to 3, right? All the way up to 3. And then it will change signs because we didn't have a double root, so then it will change signs. For acceleration, if I put in something like 1 or 0 even, I'm going to get a negative. This will be negative. And then on the other side of square root of 3, it'll be positive. And that's it, so it will continue to be positive after that. So they have different signs. Velocity and acceleration have different signs between square root of 3 and 3. So C. Okay, number 18. Particle moves along x-axis so that its velocity is given by this. At what time is the acceleration a minimum? We want the acceleration to be a minimum. Okay? So first let's find the equation for acceleration. So I'm going to take the derivative of this. That's negative 3t squared plus 9t cubed, right? So just to get a feel of what's going on here, if we were to graph this, we kind of know what a positive cubic equation looks like, right? A positive cubic equation looks like this. That's one possibility, or it could be like that, right? But that's the general shape of a cubic, right? So we want the acceleration to be a minimum on this interval. Well, if we put if we put 0 in for t, the acceleration will be 0 there, right? So we'll keep that in mind. Let's just keep that in mind. So I want to know when this is if we were looking for when anything is a minimum, we take the derivative and set it equal to 0, right? So I'm going to take the derivative of the acceleration because that's what I want to. If we were to do a closed interval test on this, starting at 0, I would then find every place that a prime is 0, right? That's what I'm doing here. So negative 6t plus 27t squared, set that equal to 0. I'm going to factor out a 3t, and I'll have negative 2 plus 9t is equal to 0. So t is 0, or t is 2/9, right? So we're looking at this shape where this is time 0 and this has to be time 2/9. And I've just answered my question for this absolute min on that interval. It has to be at 2/9. A. So that's how I would do that problem. Okay, number 19. The position of a particle on the x-axis, what is the speed at time 4? Well, speed is the absolute value of velocity, so I need to find the velocity. Velocity will be 8 minus 3t squared. The velocity at 4 is 8 minus 3 times 16, which is negative 40. The speed, remember, is the absolute value of velocity. So at time 4, that's going to be positive 40. Let's see. And last one. I'll put this back to this. Okay. So the position is given by this equation. At what time interval is the particle farthest below the origin? Farthest below the origin. Okay? So, again, we can do a closed interval test here, right? We want for the position to be a minimum on that interval, right? That's the time that the particle is furthest below the origin. So I'm going to do a closed interval test. 0 and 2 go on there, and then anything that make y 0, specifically negative to positive, right? Y prime 0. So I'm going to find y prime, which is the velocity. 3t squared minus 6t plus 3, set that equal to 0. I'm going to factor out a 3. You can divide both sides by 3 if you like. Since it's positive, it's not going to affect my signs here. I get that, right? So, yeah, that's right? So I'm going to put 1 on there because t equals 1 is my only critical value there. Okay, but also the derivative is always positive there, right? The derivative is always positive because when you square anything, it's positive. So y prime is positive on either side. So this is neither a relative min or a relative max. So it's neither. So I really don't have to go and find out. I don't need to find the value of y at that time because I know it's not going to be my absolute min, right? The absolute min has to occur at either 0 or 2. And since the velocity is always positive there, I know this particle is always moving up, right? The particle is always moving up. So the minimum has to be at the lowest time. So this has to be the minimum. And if I put 0 in for t, I get -2. So at what time is the particle farthest below the origin? 0. So again, that's how I would do that problem. Okay, hopefully this all wasn't just too terrible for you. Again, these problems for the BCs, the BC exam, these will occur in the multiple choice questions.